The Minuteman III, the heart of the US nuclear deterrent, is an intercontinental ballistic missile with global range and lethal accuracy. Operating for over 50 years, it maintains national security with full readiness and advanced command and control systems. Constantly updated, it symbolizes strategic stability in a world of increasing tensions, ensuring that any threat faces a swift and relentless retaliation. But before we begin, subscribe to our channel and leave your like. Now let's get started. Theme 1: Minuteman III and US Security. The intercontinental ballistic missile Minuteman III is a key component of the United States' nuclear deterrence strategy, symbolizing the country's capability to respond to global threats with speed, precision, and reliability. Its recent test launch, conducted at the Vandenberg Space Force Base in California, represents an important exercise to validate and ensure the readiness of this essential system for national defense. The test, which involved firing an unarmed missile, was not a response to current geopolitical events, but part of a rigorous schedule of routine evaluations that maintain the credibility of the American nuclear arsenal. This launch traveled approximately 4,200 miles over the Pacific Ocean, reaching a designated area near the Marshall Islands, carefully selected to minimize risks and allow the collection of critical flight data. The Minuteman III is equipped with a test re-entry vehicle whose main mission is to provide detailed information for future technological improvements. These updates are crucial to maintaining the United States' strategic superiority in the field of nuclear deterrence, as global stability depends on the balance of power and the ability to respond quickly to any threat. The Minuteman system is dispersed in fortified silos, protected against attacks, ensuring the missile's survival even in extreme situations. The direct and highly reliable connection to the underground control center guarantees that presidential launch commands can be executed safely and precisely. Each silo is monitored and operated by highly trained teams who remain on constant alert, ensuring immediate response capability. Moreover, to guarantee continuity of command and control, even if ground facilities are destroyed, the United States employs E-6B aircraft that act as airborne command centers, capable of taking control of isolated missiles and executing presidential orders. This strategic redundancy ensures that the nuclear deterrent system remains impenetrable and effective even in extreme conflict scenarios. The Minuteman III represents a significant technological evolution from the first intercontinental missiles of the 1960s, offering fast reaction times, advanced inertial guidance, and high resistance to external interference. The system's maintenance approach, based on rapid component replacement, guarantees an availability rate close to 100%, essential for the credibility and continuous operational readiness of the American nuclear force. Over the decades, the Minuteman system has undergone extensive modernizations, incorporating new capabilities to face emerging military and technological challenges. Among these improvements are increased accuracy, expanded targeting options, and enhanced missile survivability in hostile environments. The current system, with about 400 Minuteman III missiles distributed across 3 strategic air bases in Wyoming, Montana, and North Dakota, is designed to remain operational for the next 50 years, reflecting a long-term commitment to national security and international stability. Thus, this system is a central pillar in the defense of the United States and the maintenance of global power balance. The continuity of tests and technological upgrades ensures the country maintains a firm and deterrent posture, avoiding conflicts through a clear demonstration of its capability for effective retaliation. Therefore, the Minuteman III is not just a weapon, but a crucial element of the strategic security architecture, representing a joint effort of engineers, military personnel, and strategists to preserve peace and global stability through reliable and constant deterrence. Theme 2: Minuteman III, Security and Operation. The Minuteman III system represents a technological and operational milestone in the history of the United States' strategic defense. Originally designed in the late 1950s and deployed from the 1960s onward, it incorporated revolutionary concepts for its time, setting new standards for reaction speed, accuracy, and reliability of nuclear deterrent systems. The system uses intercontinental ballistic missiles, ICBMs, dispersed in fortified underground silos, providing robust defense against enemy attacks and ensuring the survival of nuclear retaliation capability. The Minuteman III architecture involves multiple levels of security and redundancy to ensure the system is always operational and strictly controlled by competent authorities. Each silo contains a missile equipped with advanced propulsion, navigation, and control systems, as well as a re-entry vehicle that carries nuclear warheads in the armed versions. System control is centralized in highly protected underground command and control centers that maintain constant communication with launch teams located at each silo. Launch teams consist of 2 highly trained officers who remain on alert 24/7. These officers are responsible for executing launch commands upon presidential order, acting with discipline and precision. To prevent command system failures, multiple communication layers are employed, ensuring instant and reliable contact between the President of the United States, the Secretary of Defense, and the launch teams. This sophisticated communication system significantly reduces the risk of command failure or interception. In extreme situations, if ground communication between the control center and silos is lost, an airborne system takes over missile command and control. E-6B aircraft, specially equipped to act as airborne launch control centers, are ready to enter action. They have qualified air combat crews to execute presidential orders and ensure the continuity of the U.S. nuclear capability, even if ground facilities are compromised. This level of redundancy is essential for the credibility of the deterrent system, making it nearly impenetrable to neutralization attempts. The Minuteman III system uses solid propulsion technology, which represents a significant improvement over the early liquid-fueled ICBMs. This solid technology provides faster response, easier maintenance, and lower operational risk. Navigation is guided by advanced inertial systems that allow the missile to hit targets with high accuracy, minimizing failure risk and maximizing strategic effectiveness. Additionally, the maintenance philosophy of the Minuteman system is based on a remove and replace strategy, enabling quick replacement of defective components, ensuring the system remains in a constant state of readiness. This model maintains an alert rate close to 100%, meaning the missiles are always ready for immediate launch, ensuring rapid response capability against any threat. Since its deployment, the Minuteman III has undergone several upgrades and modernizations. Continuous programs aim to enhance missile survivability, improve guidance system accuracy, and expand targeting options. These improvements are essential to maintain strategic superiority in a global scenario of constantly evolving threats. Therefore, the Minuteman III is not just a static weapon, but a dynamic system evolving to meet new challenges and missions, ensuring its relevance for decades to come. Currently, the US ICBM force consists of approximately 400 Minuteman III missiles distributed across 3 strategic air bases: the 90th Missile Wing at FE Warren Air Force Base, Wyoming, the 341st Missile Wing at Malmstrom Air Force Base, Montana, and the 91st Missile Wing at Minot Air Force Base, North Dakota. This geographic dispersion is a tactic to reduce vulnerabilities and ensure that even in the event of an initial attack, the United States maintains a reliable retaliation capability. This system is an emblematic example of how technology, military strategy, and operational discipline come together to create a deterrent force capable of maintaining world peace through power balance. The existence and maintenance of the Minuteman III reinforce the United States' commitment to protecting its national security and preserving global stability amid an increasingly complex strategic environment. Theme 3: Minuteman III and Global Stability. Routine tests of the Minuteman III intercontinental ballistic missile are an essential component to ensure the effectiveness, accuracy, and reliability of the United States nuclear deterrent system. These unarmed missile launches are planned in advance, conducted at regular intervals, and do not reflect responses to specific political or military events, but rather a continuous commitment to maintaining strategic readiness. The second test launch of the year, conducted by the Air Force from Vandenberg Space Force Base in California, demonstrated the robustness of the Minuteman III system by traveling approximately 4,200 miles over the Pacific Ocean to a pre-designated zone near the Marshall Islands. During this flight, the missile carries a test re-entry vehicle without nuclear warheads, but collects critical data on system performance, providing fundamental technical information for future updates and improvements. These tests are essential not only to validate the missile's technical capability, but also to reinforce the United States' strategic credibility with its allies and adversaries. capabilities. Demonstrating the operational capacity of the Minuteman III acts as a deterrent against potential aggression, maintaining certainty that the country possesses a modern, reliable nuclear arsenal ready to be used if necessary. This balance of power is a decisive factor in maintaining global stability, preventing nuclear conflicts through mutual deterrence. The current geopolitical landscape, marked by regional tensions and rivalries among global powers, increases the importance of these tests. Strategic stability depends on a combination of transparency, trust, and proven operational capability. By conducting these test launches, the United States demonstrates its commitment to maintaining an effective defense system while sending a clear message that its nuclear capability remains intact and functional. The rigorous nature of the tests also allows the identification of possible technical failures or areas needing improvement. Although the Minuteman III system has been in existence for over 6 decades, it is constantly modernized to incorporate technological advances that increase its accuracy, efficiency, and resistance to potential threats, including attempts at neutralization by adversaries. Each launch provides an opportunity to validate these improvements, reinforcing confidence in the system's capability. Beyond demonstrating strength, the tests serve as practical training for the teams involved in missile operations. Maintaining high readiness levels requires personnel to be familiar with launch procedures, communications, and response under real conditions. Thus, the tests ensure that Air Force personnel and associated facilities are prepared to act quickly and precisely if a real crisis arises. The commitment to continuous readiness also involves extremely sophisticated command and control systems that guarantee the security of launch orders. Multiple layers of communication, strict protocols, and operational redundancies ensure that the authority to use the Minuteman III system is exercised exclusively by the highest government officials, such as the President of the United States. This strict control is essential to prevent accidents and ensure nuclear power is used only in extreme necessity. Finally, Minuteman III tests highlight the importance of modernization and maintenance of the United States strategic defense systems, which include over 400 missiles distributed across strategically located air bases within the continental territory. This dispersion reduces vulnerabilities and reinforces retaliation capability, constituting a key pillar of the national security strategy. In summary, Minuteman III test launches are much more than technological demonstrations. They represent strategic policy aimed at preserving global peace through deterrence, ensuring nuclear power remains a reliable and controlled element in the complex landscape of contemporary international relations. Theme 4: Minuteman III, Command and Control. The Minuteman III system is not just an intercontinental ballistic missile, but part of a complex command and control network that ensures its operational readiness and safe use. The system's efficiency and security depend on a highly integrated architecture involving multiple communication layers, strict protocols, and redundancies designed to guarantee exclusive launch control by competent civilian authorities. Firstly, the Minuteman III is housed in fortified underground silos dispersed across 3 U.S. air bases: the 90th Missile Wing at F.E. Warren Air Force Base, Wyoming, the 341st Missile Wing at Malmstrom Air Force Base, Montana, and the 91st Missile Wing at Minot Air Force Base, North Dakota. This geographic dispersion is a fundamental measure to increase the arsenal's survivability in the event of a first strike, reducing the chances of total annihilation and ensuring retaliation capability. Each silo is connected to an underground launch control center, where a team of 2 officers remains on alert 24/7. This pair is responsible for maintaining the missile's operational status and executing launch orders if given. The system requires both officers' simultaneous agreement to initiate a launch, implementing a 2-key control that prevents unilateral actions. Communication between the control center and silos is conducted through reinforced cable systems and a secure communication network designed to resist interruption or interference attempts, whether conventional or cyber. This network is vital to ensure orders are transmitted without failure, even in intense conflict scenarios or electronic attacks. As an additional safety and operational continuity measure, the system includes E-6B Mercury aircraft that act as airborne command centers. These aircraft are equipped to assume control of the missiles if communication between the ground control center and silos is lost. This capability ensures that the deterrent system cannot be easily neutralized by an attack aiming to destroy ground command centers. The E-6Bs are operated by highly trained crews armed with air combat systems capable of ensuring the aircraft's survival in hostile environments. They also serve as a direct link between the President of the United States and the strategic nuclear forces, guaranteeing a nearly uninterrupted command line. The operational security security of the Minuteman III system is reinforced by extremely strict protocols regulating weapon handling, storage of launch codes, and authentication of received orders. These processes ensure the system cannot be activated by mistake, unauthorized access, or technical failures. The development of this command and control system was motivated by lessons learned during the Cold War, when the risk of human error or communication failures could have catastrophic consequences. The need to guarantee that nuclear arsenal use was a conscious, authorized, and controlled decision led to the implementation of multiple layers of security and redundancy. Moreover, the command structure is integrated with global intelligence and monitoring systems that provide crucial information for strategic decisions, including early detection of adversary missile launches. This allows the President and national security advisors to have a complete situational picture before making decisions involving nuclear weapons use. The Minuteman III system continues to undergo modernizations that not only enhance the missile's technical capabilities, but also strengthen the command and control system. This is crucial to ensure the system remains efficient and secure in the face of new threats, especially in the digital age where cyber attacks pose real risks. Therefore, the operation of the Minuteman III system results from a complex combination of advanced technology, strict protocols, and constant training of involved teams. This structure guarantees that the destructive power of the United States nuclear system is always securely controlled, serving as a crucial element in deterrence policy and national security. Theme 5: Minuteman III and U.S. Security. The Minuteman III intercontinental ballistic missile plays a central and strategic role in the United States nuclear deterrence policy since its inception over 6 decades ago. Its primary function is to ensure that any potential adversary understands that the U.S. possesses the capability, readiness, and will to respond with devastating force to any nuclear attack, thus maintaining stability and preventing nuclear conflicts. Strategic deterrence is based on the principle of reciprocity and credible threat. The Minuteman III, as part of the U.S. nuclear triad, which also includes nuclear ballistic submarines and strategic bombers, ensures the country's ability to maintain a rapid, precise, and relentless response, even in the face of an enemy's attempt to neutralize its arsenal. This is fundamental to preserving peace through prevention, as no adversary wishes to face guaranteed destruction. The fact that Minuteman III missiles are dispersed in protected underground silos located in remote areas with advanced security systems increases the reliability of America's retaliatory capability. This dispersion makes a successful surprise attack capable of destroying the entire nuclear arsenal highly unlikely. Thus, the Minuteman III system functions as both a shield and a sword simultaneously. Since the beginning of the Cold War, when the development of the first intercontinental ballistic missiles represented a technological revolution, the US recognized that the capability to launch an almost immediate retaliation was essential to prevent the enemy's use of its nuclear arsenal. The Minuteman III was designed to be highly precise and resilient, meaning it can hit critical targets efficiently, minimizing the risk of failures that could undermine deterrence. Over the years, the Minuteman III has undergone several upgrades and modernizations that have increased its effectiveness and adaptability to changing global threats. The most recent versions of the missile have advanced guidance systems and the ability to carry multiple independently targetable re-entry vehicles, MIRVs, allowing a single launch to hit multiple targets and thus expanding its deterrent capacity. Additionally, the Minuteman III system is integrated with a complex intelligence and surveillance network, ensuring that critical decisions are made based on accurate and up-to-date data. This helps avoid hasty or mistaken responses during crises, maintaining a delicate balance between readiness and control. Nuclear deterrence depends not only on the existence of the arsenal, but also on the perception that it is effective, reliable, and controlled. Periodic tests, such as unarmed missile launches, are essential to demonstrate this readiness and ensure the system continues to function as expected. These public demonstrations send clear signals to adversaries, reaffirming the US commitment to its deterrence policy. In the contemporary global context, the role of the Minuteman III remains vital. New challenges are emerging, such as the proliferation of nuclear weapons by non-aligned countries, modernization of rival powers' arsenals, and cyber threats that may compromise command and control systems. To respond to these challenges, the Minuteman III modernization program includes upgrades not only to the missiles themselves, but also improvements to the command, communication systems, and the infrastructure supporting silo operations. Despite international treaties aimed at reducing nuclear arsenals, such as the New START treaty between the US and Russia, the Minuteman III remains a fundamental component component of American defense and global security. It represents an effective barrier against nuclear aggression and helps maintain a balance of power that discourages direct confrontations between major powers. The trust placed in the Minuteman III by deterrence policy also entails enormous responsibility. Constant maintenance, launch crew training, technological modernization, and strict security protocols are essential to avoid catastrophic errors that could lead to accidental nuclear conflict. Therefore, the Minuteman III is not just a piece of military technology, it is a pillar of US security strategy and a key factor in maintaining global peace through strategic deterrence. Its role is and will continue to be indispensable in guaranteeing international stability and security in a world marked by geopolitical complexities and evolving threats. Theme 6, Minuteman III, Structure and Security. The Minuteman III system represents one of the most advanced and complex sets of military technology employed in the United States' strategic defense. Its operation involves a meticulous combination of equipment, infrastructure, security protocols, and highly trained personnel, all essential to ensure the nuclear arsenal remains secure, reliable, and ready for use in case of extreme necessity. The operational base of the Minuteman III is distributed across 3 missile wings located at strategic points in the country: the 90th Missile Wing at F.E. Warren Air Force Base in Wyoming, the 341st Missile Wing at Malmstrom Air Force Base in Montana, and the 91st Missile Wing at Minot Air Force Base in North Dakota. These locations were chosen for their remote geography and terrain favorable for building underground silos protected against external attacks, including nuclear strikes. Each silo is a technological fortress built to withstand explosions, impacts, and attacks. It is equipped with environmental and physical monitoring systems, as well as devices ensuring missile integrity and preventing unauthorized access. The silo architecture includes multiple layers of armor and redundant security systems, creating physical and electronic barriers that make sabotage attempts nearly impossible. Missile launch control is equally rigorous. Each silo is connected to an underground command center where 2 highly trained officer teams operate in 24/7 shifts. This duo is responsible for continuously monitoring missile status and receiving launch orders only through encrypted and highly secure channels. Launch protocols require simultaneous and coordinated authentication of orders by both officers, ensuring no unilateral action can fire a missile. In addition to human redundancy, the system has advanced communication lines connecting each silo to a central command where the US President and Secretary of Defense are located. If communication with ground bases is lost, specific aircraft such as the E-6B Mercury act as airborne command centers, assuming control of launch orders to ensure response capability under any circumstance. Cybersecurity is also a critical aspect of Minuteman III operation. Given advances in digital technology and increasing cyber attack threats from state and non-state actors, the system is protected by multiple layers of digital defense, including robust encryption, advanced firewalls, and continuous monitoring to detect and neutralize intrusion or sabotage attempts. System maintenance is a continuous, highly specialized task. Electronic, mechanical, and technological equipment in missiles and silos undergo regular inspections, tests, and updates to ensure flawless operation. Any detected anomaly is immediately corrected to prevent failures that could compromise operational effectiveness or safety. Training for teams is equally rigorous. Officers and technicians undergo intensive programs simulating crisis situations, technical failures, cyber attacks, and emergency protocols. The goal is to ensure that even under extreme conditions, the human and technological response is swift, coordinated, and efficient, minimizing the risk of errors. A key security component of the Minuteman III is the remove and replace policy, which provides for rapid replacement of defective or obsolete components to maintain near 100% reliability. This preventive maintenance approach allows the system to remain on maximum alert, avoiding prolonged downtime or unavailability. Physical security around the facilities is also strict. Armed guards, video surveillance systems, motion sensors, and other devices detect unauthorized access attempts. Bases are protected by specialized military forces ready to respond to any threat. Finally, the operation of the Minuteman III is surrounded by strict secrecy and confidentiality protocols. Information about exact silo locations, technical details, and operational procedures are tightly controlled to ensure the system remains protected against espionage and external threats. In summary, the operational and security structure of the Minuteman III reflects the strategic importance of this system for the United States. The combination of robust infrastructure, advanced Advanced technology, trained personnel, and strict protocols ensures the system continues to be a pillar of American nuclear deterrence, ready to respond to any threat while maintaining global stability. Theme 7, Minuteman III Modernization. Since its initial deployment in the 1960s, the Minuteman intercontinental ballistic missile system has undergone a continuous process of modernization and technological evolution to maintain its effectiveness, reliability, and relevance amid new global threats and military advances. The Minuteman III, the currently operational version, represents the pinnacle of these improvements, combining technological innovation with a robust architecture that guarantees the survival and effectiveness of the United States nuclear deterrence system. One pillar of this modernization was the improvement of the Minuteman III missile itself. Originally, the Minuteman series missiles had limited range and reduced payload capacity, as well as less precise navigation systems. Over the years, successive upgrades have extended its range, improved accuracy, and increased the capacity for multiple independently targetable re-entry vehicles, MRVs. This allowed a single Minuteman III missile to strike multiple distinct targets, drastically increasing its strategic power and effectiveness. Another fundamental aspect of modernization was the improvement of the inertial guidance system. Early models relied on less sophisticated mechanical and electronic equipment, which limited missile accuracy and increased the probability of error. With the introduction of advanced inertial navigation systems using laser gyroscopes and modern sensors, the Minuteman III's accuracy was significantly enhanced, allowing it to hit targets with minimal margin of error, vital for deterrence and combat effectiveness. Modernization also included improvements to command and control systems, with the implementation of more secure and interference-resistant encrypted communication networks. The integration of advanced and redundant digital protocols ensures that launch orders can be transmitted securely and quickly, even in conflict situations where traditional communications might be compromised. Furthermore, ground and airborne command centers were equipped with enhanced monitoring systems to guarantee system integrity and continuous functionality. An important recent project is the Ground-Based Strategic Deterrent GBSD program, which aims to gradually replace the Minuteman III with a new land-based ballistic missile system featuring even more advanced technology, greater reliability, and adaptability to future threats. The GBSD is in development to ensure the United States maintains a modern and operationally efficient deterrent force for the coming decades. Additionally, the modernization program includes continuous updates to silos and launch facilities, reinforcing their resistance to modern attacks, including those based on cyber technology or hypersonic weapons. The construction and maintenance of these facilities follow rigorous engineering standards, incorporating new shielding techniques and protection against penetration by conventional and nuclear strikes. Maintenance of the nuclear arsenal, including warheads and support systems, is also part of this evolution. The U.S. Department of Energy, responsible for nuclear warhead development and upkeep, conducts regular inspections and security upgrades to ensure devices remain safe, stable, and functional throughout their life cycle. This process involves advanced simulations, non-nuclear testing, and analysis of critical components to avoid failures. Another challenge of modernization is balancing the need to maintain a robust deterrent arsenal with international arms control policies. The U.S. participates in treaties and agreements, such as New START, which limit the number of warheads and strategic systems, encouraging modernization within parameters of responsibility and transparency. Thus, the Minuteman III's evolution respects these international commitments while maintaining national defense capability. Training and qualification of the teams operating the system also keep pace with these technological innovations. Officers and technicians receive updated instruction on new functionalities, security protocols, and responses to emerging threats. Computer simulations and real-time exercises are conducted to ensure readiness and effective response in any scenario, from technical failures to real conflicts. In summary, the modernization of the Minuteman III system reflects the strategic importance of maintaining a high-performance, reliable intercontinental ballistic missile system. Through technological advances, security improvements, and adaptations to new geopolitical realities, the system remains a fundamental component of American nuclear deterrence, ensuring stability and national security in an increasingly complex and unpredictable world. Theme 8, Minuteman III, Strategic Role Today. In a world where international relations face increasing tensions and instabilities, the role of the United States Minuteman III Intercontinental Ballistic Missile (ICBM) system remains central to maintaining peace through strategic deterrence. Deployed during the Cold War, this system has evolved to become one of the main pillars of the American nuclear triad, alongside submarine-launched ballistic missiles, SLBMs, and long-range strategic bombers. Today, its relevance remains high, being a fundamental element of national security and global stability. The essence of the deterrence concept lies in the capability of a rapid and guaranteed response. The Minuteman III system is designed to provide exactly that, a land-based nuclear strike force that can be launched within minutes, operating from dispersed and protected locations. Its missiles are stored in reinforced silos at strategically located bases such as FIE Warren, Malmstrom, and Minot, covering wide areas of the continental US. Each silo is monitored by underground control centers connected through redundant communication lines, ensuring the effective execution of central command orders, even in nuclear conflict scenarios. This system's constant readiness is not just a war tool, but a powerful political instrument. The mere existence of ICBMs serves as a deterrent against potential aggressors, ensuring that any nuclear attack against the United States would be met with devastating force. This discourages offensive moves and reduces the likelihood of large-scale conflicts. It is a delicate but effective balance that sets limits on adversarial powers' actions and guarantees room for diplomacy. Periodic tests, such as the recent one conducted from the Vandenberg Space Force Base, reinforce the system's credibility. These launches demonstrate to the international community, and especially to potential adversaries, that the system is functional, accurate, and continuously updated. Conducting these tests also allows for the collection of essential data for technical analyses and future improvements, keeping the system compatible with modern technological demands. The Minuteman III system also plays a vital role in the United States military alliances. Within the NATO framework, for example, American nuclear deterrence offers extended security guarantees to its European allies. This reduces the need for nuclear proliferation among allied nations, as they rely on the protection of a strategic partner with proven nuclear capability. Thus, the Minuteman III contributes not only to US security, but to the collective security of the West. Another aspect of Minuteman III's strategic importance relates to its survivability. Unlike bombers and submarines, which require constant movement to ensure evasion from attacks, ICBM silos offer an immediate and secure response, even in the event of a surprise attack. Additionally, E-6B aircraft known as Looking Glass serve as airborne command centers, ensuring redundancy in missile command and control even if ground facilities are compromised. Modern capabilities of the Minuteman III include high-precision guidance systems, structural reinforcement technologies, shielding against electromagnetic interference, and multiple independently targetable re-entry vehicles, MARVs. These features provide the system not only destructive power, but also operational flexibility in varied scenarios, from full retaliation to limited surgical strikes as required by a proportional response strategy. With the rise of new nuclear powers and the modernization of arsenals by countries such as China and Russia, the United States reinforces its commitment to maintaining the superiority and reliability of its strategic arsenal. The longevity and resilience of the Minuteman III testify to its robust design, but also reflect the ongoing need for modernization. The Ground-Based Strategic Deterrent (GBSD) program, which progressively replaces the Minuteman III, does not eliminate the relevance of the current system, but rather builds on it as a foundation of knowledge and doctrine. Even in times of growing focus on emerging technologies such as cyber warfare, artificial intelligence, and hypersonic weapons, ICBMs remain a key piece of the global strategic architecture. Their role goes beyond offensive power. They guarantee predictability, stability, and a balance channel in power relations. For this reason, the Minuteman III remains one of the most critical military systems today. In summary, the Minuteman III is more than a missile. It is a symbol of readiness, reliability, and commitment to national and global security. Thank you very much for watching the video. If you enjoyed our content, please subscribe to our channel and leave a like. Also, check out other interesting videos appearing right now on your screen, and I'll see you in the next video. See you next time.